All right, so we're going to talk about making predictions for scenarios that have imperfect data. So if you look at these data points, we're going to talk about how we make predictions using that. So we're going to talk about how to use graphs to help us solve problems and help us make predictions and make estimations so we know what to expect. Because if you look at each of these data points, everything we've been learning up until now, these points have been in a straight line. But you'll notice these are not in a straight line. So we're going to talk about how can we still use imperfect data like this, meaning it's not perfect and ideal and pretty as you've heard me call it. All right, so let's see. In this example, it says the graph shows the results of a survey of teachers' years of experience and number of honors level classes taught at a high school. And so it then goes on to say how many honors classes would you predict a teacher with 24 years of experience would teach? Meaning they're asking for 24 years. So you see years of experience is down here, number of honors classes is here. So if you've got 24, there is no information here. So we have to make a prediction. That's what our job is. Our job is to make a prediction. Now, we don't have a perfect line, but here's what we can do. We can draw a line as an estimation. So you've heard of this line before, but just in case you haven't, we're going to do something called a line of best fit, is what we're about to use. A line of best fit. Let's fix that, it's a little sloppy. Okay, a line of best fit is a line that goes through the middle. So do your best to estimate a line that goes through the middle of these points. Your line may not look exactly like my line. They may not be exactly the same, but they'll be close. And now looking at mine, you want to make sure there's an equal amount of dots on each side. So if you take a look, I've got 1, 2, 3, 4, 5, 6. I've got about 6, 7 dots on this side, but on this side I only have about 4. So this line is not a good estimation. This line needs some adjustment. That's what that tells us. We want it to be more reasonable. We want it to be more realistic to where there's about equal number of dots on each side of the line. So let's try that again. Let's see, I'm going to try, how about here? Okay. On both sides, it's much closer to being equal now. So that's a lot better. So now, your line, by the way, does not have to go through the origin down here. The first time it did, when I drew it, it does not have to. So do your best to draw a straight line as straight as you can. Using a ruler would be best. A line that goes down the middle of the dots. Because that line is kind of like the average. It's kind of in general, where the dot's going. So it helps you make close averaged estimations. So now, let's actually go to answer the question. The question said, how many years would we predict them to have, how many honors classes would we expect them to teach based on 24 years of experience? Well, if you go straight up from 24 years of experience, and you go straight up, you cross it right here. Well, that's just above 5, and you can't really teach 5.2 classes. You can't teach a partial class. So we're going to just round that to 5 classes. So that tells us we're expecting at 24 years, even though we know the data points aren't perfect, somewhere around 5 years. So we're going to say 5 honors classes. It's okay to round if your line of best fit doesn't give you a perfect answer, because remember, your line of best fit is an estimation, so it's okay to estimate a little bit with your answers as well, as long as it's close. You by no means should be saying 6 classes. You by no means should be saying 4 classes. So as long as it's reasonable, if you were just somewhere in the range of here to here, you'd realize it was near 5 classes. So that's what you're going to do for questions like this. You're going to draw a line of best fit, and then the examples are going to ask you to make an estimation, make a prediction. And if you read down here, it gives you a little information. It says, understand. You know the number of honors level classes taught and the number of years of experience from the graph. Look at the trends and the data on the graph. We looked at that trend. We drew a line to help it, because the line of best fit is also sometimes called the trend line. Now, and it says solve. Using the line, you can predict that a teacher with 24 years of experience would teach 5 classes. Draw that line, make your prediction. That's exactly what we just did. So let's take a look at a few more examples. All right, in these examples, we've got some problems. So take a moment to see if you can answer this question. Press pause, and if you think you already understand it, give this one a shot. Okay, let's work this question out. Using the graph below, each point on the graph represents one person in a group training for a long-distance bicycle ride. Now, you'll notice, these all represent a different person. So because of that, not every person is the same. Not every person learns or does something learns something at a constant rate or improves at a constant rate. That's why you'll notice these dots do not go in a perfectly straight line. They're all over the place, but they do have a general trend. So we're going to talk about that general trend, even though they're not perfect. So these data points fit what we know about human nature. Okay, so let's see. The point shows the number of miles that person cycles each day and the number of weeks that person has been in training. Draw a line that is close to as many of the points as possible. And if you think about this intuitively, this makes sense. The longer they spend time training, the better shape they're going to get in, the more condition they'll be in, which means they're going to be able to ride further and further every day because, one, they're probably able to ride faster, but they're also able to pedal and ride longer. So our first question says, draw a line that is close to as many of the points as possible, meaning it's asking for the line of best fit, or that trend line. So do your best to draw a line that goes down the middle of your data points. So I'm looking at that one, and I see on this side I've got 1, 2, 3, 4, about 5 dots on that side. On this side I got 1, 2, 3, 4, 5, 6, 7, about 7 dots on that side. So I'm going to make a small adjustment to mine. And honestly, it doesn't have to be perfect, so the adjustment here isn't that necessary, as long as there's lines going down the middle. So I'm not going to be picky. I'm going to show you it still works, even if you don't have it being perfect. There is a mathematical way that you drew these lines of best fits, but that's not something we need to worry about until way later in math. It's not something that's going to happen in middle school. So let's just leave that line as it is. So let's say we're done with number 1. Now, number 2, if you think you've got it from here, press pause, see if you can answer 2 and 3. All right, number 2 says, does the number of miles bicycled each day increase as the number of weeks in training increases? Meaning, does this amount increase as the number of weeks increases? And let's see, as weeks go up, 1 to 2 to 3 to 4 to 5 to 6, what is happening to the distance? You guys will notice, hey, it's also going up. And it goes all the way up in this graph to about 25 miles. So it is rising. So the answer number 2 is yes, it does. You can just say yes, because it was a yes, no question. You'll say yes. And in your way of also doing that too, if someone asks you to prove it, you could say it has a positive slope, meaning it has a positive value slope because it goes upwards. Positive slope. That's kind of a way you could justify it. Let's take a look at number 3. Number 3 says, predict the number of miles bicycled, and this is the main skill that we want to focus on, be able to make predictions. It says, predict the number of miles bicycled each day for someone who has been training for 9 weeks. So you'll notice, 9 weeks, it's not even on our graph, it's out here. So to help you visualize that estimation, I'm going to extend this graph. So 8 is about right there. I know it's not perfect. 9 is about right there. I know it's not perfect. Oh, I can't count. This is 8. That's 9. All right, so let's see. So if we were to extend that line up through 9, okay, keep that line going, you would notice, well, hey, it crosses almost perfectly with 30 miles. Where they cross right there at 9 weeks of training, right here, that crosses almost perfect with 30 miles. So remember, it's based off an estimation, so that's a very, very good, in fact, I can't believe it came out so perfect for that one. It doesn't look like it's 31 or 29. So predict the number of miles bicycled each day, someone who's been training for 9 weeks. Let's see, 9 weeks, we went straight up, it's right at 30 miles. So we're gonna say 30 miles. That's gonna be our estimation for number 3. So this was a good example of working through each of the skills you're gonna use with drawing a line of best fit and then making decisions or making judgment calls or estimations or predictions using that line of best fit. Because that line is a close indicator of what are the data points doing. Remember, it's not perfect, it's kind of like an average, but it'll be close enough for our purposes. Let's try a couple more. All right, so let's take a look at question 1 on this screen. We're going to talk about sales. It says, use the graph at the right. The graph shows the monthly sales for Wilson's Flower Shop, is what it asks us to do. Okay, now, before I continue, I'm looking ahead real fast. It tells us we're going to predict stuff for July and September. And since those are going to be out here to help you visualize it, I'm going to zoom out for a moment. So give me 1 second. All right, we're back. We're more zoomed out to make it more easy to estimate outwards. All right, so let's move on with this question. So use the graph to the right. The graph shows the monthly sales for Wilson's Flower Shop. So as the months go by, oh, it looks like the sales are going up. All right, so that's good news. It means they're making more and more money each month. All right, so it says draw a line that is close to as many points as possible. And you'll notice this line is not going to go, and do your best to estimate it. Use a ruler, use a piece of paper, or just use your hand. And it does not have to be perfect, but estimate it. And so it goes to the middle. And it does not have to go through the origin. It's not necessary. Because some situations don't. Because hopefully there's never a month where these poor souls sell $0. Hopefully it never happens. No business wants to make zero money. So that's not reasonable. So we've now done part A. Part A, check. Part B, use the graph to predict the monthly sales in July. Let's see, January, February, March, April, May, June, July. So July is right here. So I'm going to go ahead and even write that in. July. So if we go straight up, oh, it looks like it crosses pretty much perfect. So this is another one of those convenient situations. That won't always happen. Sometimes you'll have to estimate. It might be more like 5,900. But in this one, it crossed almost exactly at $6,000. So we're not going to overthink it. We're just going to say, all right, $6,000. Well, thank you for that. We've made that prediction. Make sure to pause if you haven't done so already. Make sure you try this first on your own. So that estimation worked out great for us. July, we went straight up. Now it says, use the graph to predict the monthly sales in September. Well, let's see. May, June, July, August, September. So September is about right there. So there's August about, September's about right there. So it looks like it crosses right about here. To me, that looks like it's slightly above the 7,000 mark. My line wasn't exactly very straight. So I'm going to say, for our estimation, since this is going to be September out here, and my judgment, just based on, I'm just rounding here, I see that these go in 1,000 increments, so I'm going to call that about 7,200. That's a judgment call. As long as your answer is somewhere between, I would say, 7,700 and 7,100, you'll be fine. So just my own judgment, I'm going to say $7,300. And that's okay if you felt it was something else, because maybe you were more perfect with your estimations, whereas I did a rough, quick one. It's okay if we don't exactly agree on this exact number, but let's make sure we're reasonable, meaning that number should not be more than 7,700. That number should not be less than 7,000. So keep it reasonable, and that's okay, because we're just making a prediction. And this is something that business owners do. They know, they track their income. They can do stuff like this where they want to predict, what can I expect to happen in September, so that they can make sure that, one, they're prepared, make sure they order enough flour so they have it. So this is a reasonable skill and and it's a very straightforward method to be able to work this out to answer these types of questions. So in each of these questions, they're going to ask you to do a line of best fit. They're going to ask you to answer a few questions based on your line of best fit. Sometimes it might even be finding the slope of your line of best fit. Like maybe how much are sales going up for every month. And so in this example, you could do that. You could, even though it'd be an estimation, that's okay. You would say, let's see. I can use this. I can use the point right here. If the question was how much do sales go up in 1 month, I would personally use those 2 points. That one is about 4,200. That one's about 5,000. So that means it goes up $800. So 5,000 minus about 4,200 for that first point. So it goes up about $800. And let's see, it goes over 2 months. 1 month, 2 months between those. So it'd be about 800 over 2, and that would simplify to 400 over 1. And that would tell us the change in income goes up $400 every month. That would be our estimation. Because you can do that. You can combine what we've learned about slopes and constant rates of change and apply them to questions of lines of best fit. Yes, I know it's an estimation. I know that wasn't perfect. Who knew that was 4,200? That was my judgment, my estimation. So your numbers may be slightly different than mine if you were to answer this exact same question, because maybe your line of best fit was slightly different. But again, they'll be close and they'll be reasonable. All we want to know is that the answers are reasonable. So as long as your answers are reasonable, you got nothing to worry about. You're doing perfect. Other than that, this is really everything you need to know right now for using lines of best fit to make predictions and to use graphs with imperfect data that's not in a perfect straight line, to use it to help you make judgment calls so that you can help run a business, or so that you can also maybe be a trusted advisor. So good luck and apply this to each of your questions.